Okay, folks, here's the quick once over on the law of sines. This is used to solve any triangle, does not have to be a right triangle. And for this process, we want to see if we have numbers or something we're looking for on matching lettered sides and angles. So for example, angle B and B, and angle A and A. If you can circle these matching letters in loops, and you have 3 out of 4 numbers with a missing letter or a side you wish to find. You can also use any combination of these 2 loops, for example. So we'll see number examples here in just a bit, as we did in class the other day. But if we can do these loops here like this, and have 3 out of 4 numbers, we can use the law of sines, and by that we mean we can use 2 out of these 3 matched sets at a time, and we can pair them up any way we want, right? We could use sine of A over A, that will equal sine of B over B. And where was I here? We can also group the sine of B over B with the sine of C over C, and if we wish, we can match up the sine of A over A with the sine of C over C, as long as we're taking basically 2 out of these 3 fractions at once. When we do so, of course, we set up a proportion, which we solve by cross multiply. So let's see, here we go to our example 1. And if I think about that loop situation, notice here I have numbers in both spots, and here I have a single number. So what I should be then trying to solve for is the measurement here of side A. And then coming back, I could also potentially solve for side C. And to do that, I need to know angle C, but of course, since we know 2 out of 3, I can simply find angle C by subtraction from 180. So let's continue with the actual setup for this problem then. Sine of A divided by little a equals sine of 28 divided by the matching side across the way, 9. Then, as we always have for these, we solve basically, here's our loop situation again, isn't it? It's 9 times sine of 44 equals A times sine of 28. And then, of course, to get the A by itself, our math step is to divide by sine of 28. Do that both sides. And then, of course, carry out the calculator arithmetic over here to get an example and answer for letter A. And as I grab my calculator here and turn it on, 9 times sine of 44, enter, divided by sine 28, enter. Calculator tells me 13.31 about 7. So A here is about 317, just to keep some extra decimal places. And does that answer make sense? Well, if you look at the original loops here, the 9 length side is across from the 28-degree angle, and we see the A is across from 44, so we would expect this A size to be a little bit bigger than 9, and of course it is. And then lastly, if we do want to solve for C, if they do ask us to find the entire triangle, or actually the word is solve the triangle, we do want to find all sides and all angles. When we find angle C by subtraction, let's see, 44 plus 28 is that much, and 180 minus second negative sign to pull that answer back in. It tells me here that the angle for C then is 108 degrees, and I could continue to find the other missing side if I were asked to do so. Next example. Again, we'll refer to our loop kind of thinking, full of numbers, and this is the side I would be looking for. Since it's across the way from capital A, I label it small a, and basically this across from idea reminds me that when we learned SOHCAHTOA, sine is opposite over hypotenuse. So conveniently, the law of sines has this opposite sort of idea involved with it. So let's write our proportion, and to do that, let's set up our proportion here before we start. And I have sine of 38 from angle B over the length of small b, and then I have the sine of 21 degrees, let's put those degree symbols on there, over length I'm looking for A. Now, just by looking at the angles that are across the way, it appears to me that A should turn out to be a little bit shorter than 24. Once again, cross multiply. I get A times sine 38 equals 24 times sine, running out of room here, 21. And then, of course, the solving step, divide by sine 38, both sides. That gives me the math here to solve. So, calculator time. 24 times sine of, let me look at it again, 21, enter, divide by sine 38. Gives me an answer of 13.97. So A is about 13.97. Here it does say, if you look back up to the direction, solve the entire triangle. So our job now is to find letter C. We do that by subtracting, so I go 180 minus 21 minus 38. Enter. It tells me angle C, put that in black, is a 121 degree angle, and I have to then solve for small c. So I can write sine of 121 over c equals sine of, which one should we go back to? Let's go back and use b because we had solid concrete whole numbers there. Sine of 38 over 24, rather than using my approximate value of 13.97, even though it was very close. So, by cross multiply, 24 times sine 121 will equal c times the sine of 38, and to save time and space, I'm going to have to divide by that sine of 38 once again over here. So now we hit the machine. Well, not literally. 24 times sine of 121, enter, divided by sine of 38. Gives us an answer of 33.41, which seems to be pretty close to what we'd expect there. Try to make that a little more legible. So now we have solved the triangle. We have values for angle A, angle B, angle C, and for small a, small b, small c. Last example to solve without all the explanation. Loops, loops. This time, however, sine 36 over 24 equals something over 34. Here I need to write the sine of b. So when I multiply, cross multiply these two, what will I be dividing back by on the other side? It looks like my 24. So I'm going to end up with something where it says the sine of b equals. So let's try this. 34 times sine 36, enter, divide by 24, enter, gives me about 0.8327 if I round to 4 places. Now we're looking for an angle measure in degrees. How do we go backwards? I think most of us might remember if we're looking for angles, we have to use the inverse sine of the trig ratio, and that should generate for me a degree answer. So second sine, I'll just pull in my entire answer, second negative sine, and I get about 56.4 degrees, which is a decent looking number as far as an answer for degrees. So then if I have b at 56.4, I can, by subtraction from 180 minus answer, minus my other angle of 36, leaves me about 87.6 degrees for this angle. And then with this idea then of using the angle and the side opposite, I can solve for side C. Once again, setting up a proportion like sine 36 degrees over 24 equals sine of angle C, 87.6 over small c, and solving again by cross multiply. I'll be dividing by the sine of 36 in this one, and I get an answer of about 40.8. for the side length. That's all there's to it. We will tackle the law of cosines in a later version. Thanks. Good luck with your practice.